right, class. So welcome to part two of the video. And here we're going to practice some procedural skills. I definitely want to show you my technique. Again, not everyone teaches it like this, I think, but I like to do it this way. And I think it'll make your life easier. So what I'm going to do is I'm going to be very, very careful when I circle what I believe needs to switch to the other side. Okay. Be careful not to include negative values if they're not part of the base, right? So for something like number 10, get in the habit, circle, right? And this is something I would love to see in your homework too. Like when you write down the original problem and then you circle the only base that has the negative exponent, then you just leave, kind of show that it goes to the other side. You end up getting B4 over A to the third. It is that simple, class. Number 11, you can see that I have a negative exponent over here. I'm going to circle just the 2. The negative technically is on the top, and then the 2 drops to the bottom. So I get negative 1 over 2 squared, right? So this negative exponent tells this base to flip to the other side, and then the exponent becomes positive. This is negative 1/4. Okay. Something like number 12, really simple. Um, you circle it on the denominator, and then you flip it back to the numerator, right? It's telling you to go to the other side. 12 is going to be a to the 5th power. Okay. So I did that really fast, but I really, really hope you use this method of circling what you know has to switch. Okay. Now, this is a strategy you can use. Obviously, when you're working with something like number 13, you can then just also add n to the negative 2 and n cubed first and just see what the sum would be. Because we know that if we have n to the negative 2 times n cubed, you would literally add them, right? You would add the exponents and you would get a positive number. Okay. Don't forget that we technically are multiplying when we add the exponents, right? We're multiplying. So here, 4 times 3 is 12, and then the n negative 2 and n cubed is 12n. Okay. What I like to do with something like 14 is I like to distribute the 2 to the power, and I get m to the negative 6. And then obviously, you can't leave it like that. Your answer is 1 over m to the 6. Okay, so you can see how these questions go pretty fast. Okay. Something like number 15, we're dividing. So 8 divided by 4 is a whole number of 2. So I know that 2 is in my final answer. I then also know that I have to switch the a to the negative 2 to the denominator, and I have to switch the b to the negative 3 to the numerator. Okay, so I already know my final answer. It's 2b cubed over a squared. Okay. I'm going to go ahead and let you try 16, 17, and 18. And we'll talk about this in class. I want you to try these 3. Okay, so number 19. For what values of n is n to the negative 3 equal to 1 over n to the 5th? Okay, so it's kind of like asking you, when is 1 over n to the 3rd equal to 1 over n to the 5th? Okay, so this is conceptual. This is a conceptual question. It's kind of asking you, when would n cubed ever equal n to the 5th? Okay, so the first thing I want you to identify is these are both odd exponents, right? Which means that if I were to plug in a negative value into n, it would still be a negative value because there's an odd amount of the power. However, you can't plug in anything other than 1 for these two to ever be the same. So for this reason, the answer is 1. Obviously, 1 will work, right? And then negative 1 will also work. Okay. So now we've practiced negative exponents. It's time to go into the concept of zero, an exponent to the zero power. And this is a great example. So let's read this. Erica explains that x squared divided by x squared equals x to the second power minus 2. And x2 to the minus 2 is x to the 0. Because the exponent is 0, Erica says that x squared divided by x squared is equal to 0. Is that correct? Barry disagrees with Erica and explains that x squared divided by x squared simplifies to 1. Who is correct, right? Would x squared divided by x squared ever equal 0? So you would say Barry is correct. Any base with an exponent of 0 will be equivalent to 1. Okay, any power, any base, a to the 0 power is equal to 1. 100,000 to the 0 power is equal to 1. Something to the 0 power, class, just means that you have equal parts on the numerator and the denominator. So like x to the 100 divided by x to the 100, you have 100 x's on top and 100 x's on the bottom. They all cancel with each other, and that's going to equal 1. So anything to the 0 power is equal to 1. Just remember that. However, if I have a negative in front of my term, then it's going to equal the negative 1, right? So 100 to the 0 power is 1. We know that's correct. However, negative 5 to the 0 power, we remember that 5 to the 0 is 1, but then we attach the negative at the end. So this is very, very tricky. Got to be careful here. This is not 1, it's negative 1. Okay. 0 to the 0. Oh, I'm sorry, I'm getting ahead of myself. Negative 7 to the 0 is equal to 1. That's no problem. 0 to the 0 is a huge debate. Maybe not even a debate. You can't set 0 over 0, right? So 0 over 0 doesn't even exist. So it does not exist. And that's why 0 to the 0 power is also not correct. All right. So one more page. Let's see. This is going to be page. Am I missing a page? What page is it? Oh, 22. Okay, so let's go to 22. Which is greater, negative 3 to the 0 power or negative 3 to the 0? We just talked about this. You have to be careful here. If there's something to be careful about this module class, it's when does the exponent touch the base and is the negative part of that base? You can see in multiple lessons now, we've seen situations where we give you a base that has a negative in front of it, but no parentheses. And then we give you a base with a negative with parentheses. And we're really asking you to really figure out the difference, right? Negative 3 to the 0 is equal to negative 1 times 3 to the 0, technically, right? Whereas negative 3 to the 0 is literally just 1. Okay, so this is going to be negative 1. And you would say, the parentheses dictates, I'll just say something like this. The parentheses dictates whether the negative is included or not. Okay. So let's practice with simplifying. Simplify and order from least to greatest. Okay. Negative 6 to the 4th power, negative 6 to the 1. 0 power. Well, we know that's 1. Negative 6 to the 4th power with no parentheses. And then negative 6 to the negative 4th power. Okay. So let's first talk about negative 6 to the fourth power. That's going to be negative 6 times negative 6, right? It's 4 of them. Really, that's 36 times 36, which I don't know by memory, and I'm a little embarrassed about that. 36 times 36. Oh, 1296. How did I not know that? 1296. Okay. Negative 6 to the fourth. That's technically negative 1296, right? And then negative 6 to the negative fourth is technically 1 over negative 6 to the fourth, which is 1 over 1296. So in terms of what's least to greatest, obviously the most negative number is the smallest. So it's negative 6 to the fourth. The second smallest number here would be this fraction, 1 over 1296, which is negative 6 to the negative fourth. And then you have negative 6 to the 0, followed by the largest, which is negative 6 to the fourth. Okay. 25 through 32 class, I think this is an excellent time for you to practice. Because you could see that this is all multiplication, I like to just add the exponents. That's really, really simple, right? 8 to the 0 is just 1, so you can even cancel that. And then 8, negative 3, and 8, 5 is literally 8 squared, which then you have to simplify to 64. Okay. Something like 26, I would distribute the 3 to every power, and then I would add them all up. Or you could simplify first and then distribute. Honestly, actually, I'm sorry. Simplifying first would probably make your life a little bit easier. So simplify, x to the 0 is gone, y and y4. This becomes 3x cubed, y5, with a 3 on the outside. Okay. So, like I said earlier, when you have a degree on the outside of the parentheses, it has to distribute to every degree on the inside. Notice how even the 3 has to have a degree. The 3 has an invisible 1. So this becomes 3 cubed x9 y15. You're multiplying. This is from the previous lesson. And then 3 cubed, you have to calculate. 3 cubed is 27. Okay. Let's try something that looks very, very intimidating. Let's try 29. So 29. There's negative exponents everywhere. I would say first, simplify anything if possible. And I noticed that the 2 to the negative 1 with the negative 2, that should probably be 2 to the squared power, right? 2 squared. So I'm going to rewrite everything just so you could see, and I'm going to show you my style. This is how I like to solve. Okay. So I didn't do anything to the numerator. This right here, the 2 to the negative 1 with the negative 2, I'm going to write that as 2 squared. There's a k that's positive. There's a t that's negative 3. Okay, so this is how I like to do it so you don't get confused. I like the oval method, the sideways oval. Okay, I literally circle anything, any exponent that is negative, and I say push, push to the other side, push to the other side, push to the other side. Yes, that's kind of messy, but it really helps me organize where are my negative exponents and switch them all to the other side. Okay, so there's only one term on the top. It's kind of funny. Only one term got switched back to the top, and that's t to the negative 3. So I'm going to write this t to the third because it's positive now. And all three of these terms on the top were switched to the bottom. Okay. So let's calculate. 10 to the 1 power is 10. There's also a 2 squared, which is 4, right? So it's really just 4 times 10. And then I have K3 that switched from the top to the bottom. K3 and K is going to be K4. And then T5 switch to the bottom. Okay, still not done though. You can see that there's now a T cubed and a T5, right, on top and on bottom. So the T cubed will cancel with 3 of the T's on the bottom, and you'll get T squared. Your final answer is 1 over 40K 4T squared. Okay. That one was a little bit on the more challenging side. I mean, obviously, these last 4 are challenging. I'd love to talk about this with you in class. One last thing I'll say is try to simplify your group before you distribute. That's my tip. Right? So if you look at something like number 30, you could actually simplify the group first before you try to distribute the -2. Because why would you distribute to something that's not even that clean yet? You want to make this group very, very clean first. So if I were to simplify, you can see an x on top and an x on bottom. I'm canceling that immediately. 2 over 4 is 1/2, and then 1/2 to the -2. We know that all you have to do is you can distribute it, or you could just flip this to its reciprocal, 2 over 1, and then you just square it, because that the negative exponent tells the base to flip to its reciprocal. Final answer for number 30 is 4. Okay, I'm going to leave 31 and 32 for you to do as a challenge problem. Definitely want to go over them, but let's talk about that in class. Thanks for watching.